As I was saying, the one thing that we're trying to do today is to really characterize the system. We're trying to understand how to build the software on board station and here on the robot. The second thing we're trying to do is to do a simulation of a possible future lunar mission. This is a mission concept that was developed by the University of Colorado at Boulder. It's the idea of deploying a radio telescope on the far side of the moon to really try to make observations of what's called the cosmic dawn, or really the very early history of the solar system. And for us to do this, we're trying to simulate how to use a robot to lay out a actual radio telescope. And the series of tests that we're doing look at different parts of that mission. So there's a ground survey, there's a deployment of telescope, and then there's an inspection of that telescope. So this is, as I was saying, one of our multi-mission operation centers here at Ames. It's what we use to support different kinds of missions. Today, the mission that we're supporting is our robotics tests, and that means we're hooked in a couple places. One is we have live feeds from our outdoor test area, the roverscape, which you'll see later. It's a pretty large area, about the size of 2 football fields, and we have a 4-wheeled planetary rover out there called K10. We also have feeds coming out from the space station. On the screen there at the top right, that's actually a view from the space station of it's actually a Lenovo ThinkPad, and just an everyday off-the-shelf commercial computer system. Just happens to be 250 miles above the Earth, and it's running our software that we created here at Ames to remotely operate the robot. What we see here on the left here, that's one of our 3D user interfaces. It allows us to monitor the robot. It displays the robot's position, information about its battery level, its health. We have camera views that are coming down from the robot. And the people that are in front of them are on console right now. They're talking to people at Mission Control in Houston, as well as at the Marshall Space Flight Center in Huntsville, Alabama. So they're coordinating to Mission Control, and they're talking up to the space station to coordinate the activity with Luca. We also have a couple other people here. You don't actually really need a full room full of people to interact with the system. One of the things that I said earlier we're trying to do is to really operate the system and learn about the system. So we're actually doing engineering science. We have somebody who's really trying to understand what is the workload, so how tough is it for the astronaut to use this system. How good of awareness does he have of where the robot is and what is it doing? We're trying to characterize the amount of data being sent up and down the space station. So lots of different pieces here that we're trying to measure in order to understand how well does the system work and how can we improve it.
What types of data does the driver, the astronaut, use to control how eyes, where the rover is?
Actually, he uses eyes. He actually uses his own eyes. He has an interface very much like the one you see here on the display. So it's a first-person 3D kind of view. He sees camera images through the cameras in front of the robot. So it's a 3D map display, and this video stream, we can actually get a good view of where the robot is relative to the area.
So if the visual goes out, what's the plan B? Is it a 3D map display and coordinates?
It's a 3D map display. So the thing is, all the information is transmitted all together. So if we lose the data or anything, of course, then we don't have anything. And actually, that's part of our operations here. The robot is actually fairly intelligent. It's not just a remote control car. You can give it commands and say, well, drive from point A to point B, take a camera image, drive to point C, use a 3D laser scanner. So it's basically a sequence of commands, and send it to the robot, executes it by itself. So even if we can't talk to it, it can still be doing work. Now when we reestablish communications, it sends all the information back.
Are you losing communication sometimes, or loss of signal using the TGIS network, right?
Yes, we're using the TGIS network, so it's a geosynchronous system here. We don't have continuous coverage. We actually have pretty good coverage, but today we actually have a couple planned periods. In fact, right now I believe we're just emerging from one of those LOS periods.
So if you do this on Mars, for example, you'd have to have a network of satellites or just do it over ground passes?
In fact, one of the things we're interested in doing is looking at scenarios where you have basically a point-to-point radio link. So from a spacecraft in orbit directly to a robot on the ground. And in that case, if you're able to basically remain stationary, you can have continuous coverage, but if you're orbiting, you'll have to do it in passes. And that's why the ability for the robot to operate by itself is really important. so it can actually keep being productive even if we're not talking to it.
Right. Yeah, it always seemed to me like it'd be so much cheaper to do telerobotics and still do great real-time exploration on Mars and actually landing and coming back. It seems cost prohibitive.
Yeah, well, it's really fascinating to me that you start seeing these remotely operated robots more and more in everyday life. You've probably seen there are a lot of these companies building telepresence robots, where you can actually live in one part of the country and work in another. Well, we're trying to do almost the same thing here. Astronauts in space have robots on the ground. That's really, I think, just allowing us as humans to expand our reach.
Do you do any research with voice activation, voice controls, commands?
Yeah, we're really interested in all kinds of different modalities of control, voice, gesture, standard 2D, 3D interfaces. There's no single one right way to operate robots, and I think the combination is really important.
What about avatars or doing stuff using like?
Well, we
Connect
yeah. So we actually consider K10 to be like an avatar, in the sense that we are taking the information from the cameras and providing that to the operator. The operator really has a good sense that he's at the surface here, and so you don't need to have a fully immersive, full body experience. You can still feel present, even through robots like K2.
But the technology seems like it exists where you could do that, right? You could take a Kinect where it maps your body and move the robot as you move, right?
Yes, you could do that. It gets to be a little bit fatiguing though after a long period of time. So the reason why it's called K10 is because the robot before it was called K9.
Was it called K9 just because it's cute?
Well, it was called K9 for a couple reasons. One is at that time there were a ton of people in the group that were huge Doctor Who fans. And of course the robot on Doctor Who, the dog robot, is K9. And it was called K9 because the chassis, this is a longer story than I guess at the beginning, the chassis that we built that on was actually created at JPL, and it was called a Fido chassis. We brought it here, we modified it, so it's still a dog, so it went K9. And then when we came to build K10, well, frankly, we just weren't creative enough. And so, it's the next version, so K10.
When was K9?
K9 was back in, it's about more than 10 years ago. It was in the late, I guess late 1990s, early 2000s.
So Ames has been working on telerobotics for quite some time.
Yeah, the group here has been working on telerobotics for at least 20 years.
Oh, wow, okay.
Yeah, in Doctor Who there was two K9s. The first one got destroyed.
Yes, that's. Well, actually, I believe there's K9 Mark III at one point as well. So.
You guys work with First Robotics, the educational?
There is actually a FIRST team here at the center that is actually tied into the Office of Education. The group that I run is a research and development group, and we've had people that occasionally work with it, but we don't really work with them directly.
Okay.
Now, that's a correct understanding. What you need to do is reload the plan and then tell the robot to go to the next destination by skipping the steps that were already completed before it got stuck at the obstacle. The goal that you're trying to go to. That looks great, Luca. One other thing, we are going to actually restart the workbench between our phases. So we'll do phase 2 and restart the workbench, and then phase 3. Also, we'll restart it right now from between training and ops. Copy that. Just one last tip. When we're asking you to fill out the questionnaire, please don't refer back to the UI because we want to look at your situational awareness.
After this, we want to be right.
Yeah, Ames, you can see some of our software right now. So we're getting a live feed from roverscape. So we have mission operations here is talking to ISS, communication, and then we have a bunch of robot wranglers who are over at the test site where the rovers actually is, which is just the opposite side of the base.
Well, you guys are doing a good job, so kudos to you and your team.
But I believe it's supposed to be running the whole entire thing.
Yeah. Well, it's the nature of the beast with social media. It's always changing. There's always something new and better.
Oh,
and
yeah.
way to do it.
So that's the
Definitely
feed.
do it.
We're all excited. It is floating as a service. Low gravity.
Looks like it's
Because I think that'd be an interesting story, because a lot of people, the worst thing is that this is very elitist NASA socials in some ways, because people can't afford to fly gallivanting across the country to go to these.
Yeah, now it's 3 days.